Hi students, in this video we are going to see the electrostatic force. Electrostatic force is also known as Coulomb's law from the scientist Charles Augustin de Coulomb. According to him, the force between 2 point charges is directly proportional to the magnitude of each charge, inversely proportional to the square of the separation between their centers, and directed along the line connecting their centers. So here you see from the figure that the positive charges repel each other with a force of F, and positive and negative charges attract each other with the equal but opposite force of F. This F is directly proportional to the multiplication of the charges and inversely proportional to the square of the distance between them. Here what is important that the Q2 charge repels the Q1 charge with a force of F, and Q1 charge repels the Q2 with a force of F. These two charges are equal but opposite in direction. So D is the distance between the charges. Here we have from the formula that the K, which is an electrostatic constant, has a value of 9 times 9 to the power 9 Newton meter square per Coulomb square. It is a constant that will be given to you, times the multiplication of the charges Q1 over Q2 over the distance square. One electron carries a charge of 1.6 times 10 to the minus 9 Coulomb. If the number of electrons is given, then we can find the amount of charge from this equation. In this example, if the Q2 charge doesn't move, find the charge of Q3 in terms of Q. If Q2 doesn't move, that means that the net force applied on Q2 is 0. These are given as positive charges, so Q1 repels Q2, let's say with a force of F1. So Q3 also should repel Q2, let's say with a force of F3, in order to get the total charge 0. So they should be equal. F1 is equal to F3. F1 is equal to the force of Q1 on Q2 over D square. F3 is equal to the force of Q3 on Q2 over D square. So K cancel each other, Q2 cancel each other. Let's put the values. Q1 is equal to 3Q over the distance between them is 2 meters, so take D square 2 square, which is equal to 4, is equal to Q3 over the distance of Q3 to Q2 is 4 meters. So take the square of it, it is 16. So when these cancel each other, we have found the Q3 as 12 Coulomb. Also, as it repelled, it is also a positive charge. 3 charges are placed in the same straight line. If the force A exerts on B is F, A is negative, B is positive, so A attracts B with a force of F. What is the net electrostatic force on B? So F is equal to K times the charge of QA times the charge of QB over the distance square, which is equal to D. So 2KQ square over D square is equal to F. C is positive, so C will also repel B, let's say with a force of FC. FC here is equal to K times the charge of C 2Q times the charge of B 2Q over the distance square 2D square, which is equal to 4D square. which is equal to kq square over d square. As 2kq square over d square is equal to F, then this is equal to F over 2. So B has a force of F and F over 2 in the left direction. So the net force on B is equal to 3F over 2 in the left direction. Here the net force F on QC is given, and we are asked to find the ratio QA over QB. Now we are going to separate the force F into its components. It's going one in left direction, let's say F prime, and two segments in the down direction, let's say 2F prime. F prime will be applied by QA and it repels. So I can say that if this is positive, then this should also be positive. So F prime is equal to the force applied by QA on QC over the distance is equal to 4 segments, 4 square 16. Now to F, it is directed into the QB, so I can say that QB attract QC, so it should be negatively charged. So 2F prime is equal to K times QB times QC over the distance is 2, so square 4. When we take the ratio, these cancel each other. So I have 4 over 2 is equal to QA over QB, which is equal to 2. As A is positive and B is negative, so the ratio is equal to -2. A similar example again, the net force on Q3 is given. Find the ratio of Q1 over Q2. Now again I separate the F into its components. This F prime in left direction and 2F prime in down direction. Q1 repel Q3, so if Q3 is positive, then Q1 is also positive with a force of F prime. So F prime is equal to K times Q1 times Q3 over the segment 2 to square 4. To F prime is applied by Q2 and it also repels Q3, so it should also be positive. So 2F prime is equal to K times Q2 times Q3 over the distance to square 4. So when we take the ratio and cancel these values, I find 1 over 2 is equal to Q1 over Q2. As they are both positive, then the value is also positive.